In the last lesson, we learned about parallelograms. We learned that if we know something is a parallelogram, we know its opposite sides are congruent, its opposite angles are congruent. We learned that the consecutive angles are supplementary. We learned things like that. In this lesson, we're going to show how to prove something is a parallelogram. So if we know, we can do that using these four theorems. The first one says, if both pairs of opposite sides of the quadrilateral are congruent, then the quadrilateral is a parallelogram. So if I show you a shape and you know that BC is congruent to AD, and you know that AB is congruent to CD, then you know that shape is a parallelogram. The second theorem we can use to prove something's a parallelogram is by proving its opposite angles are congruent. This says if the opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. The fourth one says, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So we would just, for this one, need to show that BC is parallel to AD and that BC is congruent to AD. And the last one we're going to use for proving something is a parallelogram is if the diagonals bisect each other. So if BD bisects AC and AC bisects BD. So you see this and this piece are the same, and this piece and this piece are the same. Notice that all four sides do not have to be the same. Those are the four theorems that we're going to look at today. Okay, the first thing this says is to state the theorem you can use to show that the quadrilateral is a parallelogram. So in picture 3, they show us that this angle and this angle, those are both 100 degrees. So they're congruent. And they tell us that this angle up here is the same as this angle down here. So you look at these theorems and say, which of these theorems says if the opposite angles are congruent, then it's a parallelogram? Well, that's this one down here at the bottom, the parallel opposite angles converse. So we could use the parallel opposite angles converse to prove that number 3 is a parallelogram. Number 4, you see that the opposite sides are congruent. So for this one, we would use the parallel opposite sides converse that says if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So we would use that one. Number 5, this is a picture that shows that the diagonals are bisecting each other. You see that this is the midpoint for both diagonals. And so we would use the parallelogram diagonals converse that says if the diagonals of quadrilateral bisect each other, then the quadrilateral is a parallelogram. And then for number 7, it's showing us that these two opposite sides are both 9, so they're congruent, and the arrows tell us that they're parallel. So by the opposite sides parallel and congruent theorem, this one's also a parallelogram. So here we're just practicing tying the picture to the theorems. Okay, here it says, find the values of x and y that make the quadrilateral a parallelogram. Well, looking at number 9, we see that they're telling us about the angles. Well, the parallel opposite angles converse says that if the opposite angles are congruent, then it's a parallelogram. So y would need to equal 66 degrees, and x would need to equal 114 degrees. On number 10, they're giving us side lengths, and so we know that the parallel opposite sides converse. Let's see. This one up here at the top says that if the opposite sides are congruent, then it's a parallelogram. So if x is equal to 16 and y is equal to 9, this would need to be, that would make this a parallelogram. Okay, here we're still finding the values of x that make it a parallelogram. They've shown us that these two pieces are already congruent, so we know that's the midpoint of this segment. Now we need to show that this side is congruent to this side, and that only works if 4x plus 2 is equal to 5x minus 6. So if we solve this equation, subtract 4x, add 6, and x is equal to 8. So as long as x is equal to 8, then the diagonals bisect each other. For 14, it shows us that these opposite sides are parallel using the arrows. So in order for them to be congruent, 2x plus 3 would need to equal x plus 7. So if I solve that equation, I get x is equal to 4. So if x is equal to 4, then those two sides are congruent, and since they're also parallel, we know that it would be a parallelogram. Okay, now we're going to talk about how do you prove these things. So in those examples, they either told us the lines were parallel or they told us they were congruent. How can we prove that lines are parallel if they don't give us the markings? Well, one of the ways we can do that is by showing they have the same slope. Lines are parallel if they have the same slope. So we can either do rise over run, or we can use the slope formula, y2 minus y1 over x2 minus x1. So if you want to show that two sides of a parallelogram are parallel, then you can either use rise over run or you can use the slope formula. Now sometimes we know that things like the opposite sides need to be congruent. If we want to find whether or not they're congruent, we need to calculate their length. Well, we can calculate their length either by using the Pythagorean theorem, a squared plus b squared equals c squared, or we can use the distance formula that we talked about earlier. And remember, the distance formula is just another version of the Pythagorean theorem. And the distance formula is the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, it can be kind of a complicated formula to use because there's a lot of places to make some calculation errors. So lots of times, especially if we're given the shape on a coordinate plane, I prefer to use the Pythagorean theorem if I want to find the length. And then the last thing that we might need to prove is to prove that two segments have the same midpoint. This is showing that they bisect each other. If they have the same midpoint, they bisect each other. And we would do that by using the midpoint formula. And the midpoint formula, remember, is just averaging the x values and averaging the y's. So we would add x1 to x2 and divide by 2, and add y1 to y2 and divide by 2. And that would give us the midpoint. And of course, if it was for two segments, you would need to show that for each segment. Okay, so now we're going to jump into actually proving that a parallelogram is, that a quadrilateral is actually a parallelogram. So in this one, I'm asking you to show that ABCD is a parallelogram by using the parallelogram opposite sides converse. And the opposite sides converse is the one that says that the opposite sides must be congruent to each other. So that means we need to show that AB, let's write it over here, that AB is equal to CD, that AB is equal to CD, and then you also need to show that BC is equal to AD. Well, if we want to show that those are equal, we need to find their lengths. So we're going to start out, since we have a coordinate plane, I'm going to go ahead and use the Pythagorean theorem. So I'm going to start out by finding the length of AB. So I'm going to do a squared plus b squared equals c squared. And remember, to find AB, we're just going to make a right triangle. We're going to go up and over. This has a vertical change of 2 and a horizontal change of 5. So A is 2 and B is 5. 4 plus 25. is 29. So the square root of 29 is c. So I'm going to shrink that just a bit. Okay, now we're going to find the length. I needed to show that was the same as DC. So now I'm going to find the length of DC. So I'm going to make my right triangle. Okay, see, this is 2 and this is 5. So I'm going to use a squared plus b squared equals c squared. And you'll see that this looks very much the same, so we know it's going to end up the same, but we're proving that we have the math to back it up. So the square root of 29 is equal to c. So we see that AB and DC are both the length of the square root of 29, so they are congruent. Now let's find our other two sides. So let's find BC, this side over here. We'll make our right triangle. That was over 3 and down 3, so A and B are both C. I'm sorry, both A and B are both 3. So 3 squared plus 3 squared equals C squared. 9 plus 9 is 18. So it's the square root of 18 is C. And we know that the square root of 18 does simplify since it's 9 times 2. So C is actually 3 times the square root of 2. Let me shrink this up before. 3 times the square root. And then we'll do the last one. We need to show that BC was equal to AD. So this is another 3 by 3 triangle, so I see that it's going to be the same. But again, we're going to prove it with our math. A squared plus b squared equals c squared. Our legs are both 3. Don't try to shortcut this formula. We've got to use it all the way through. The square root, and we get 3 times the square root of 2 is equal to c. All right, so we have shown by the math that the opposite sides are congruent, and now we need to explain what we have found. So by our math, we found that AB is equal to DC, and that BC is equal to AD, and since the opposite sides are congruent, it's a parallelogram. So that's what you're going to write once you're done with all your math. You're going to have a written explanation. So we will say, since AB is equal to CD and BC is equal to AD by the opposite sides congruent converse, ABCD is a parallelogram. This last sentence is important, so I want you to be sure that you include it. Anytime I ask you to prove something, I'm going to ask for the math, and then I'm going to ask for the statement. So I want to see you use both. Okay. We have a second question here that asks us to prove that this quadrilateral is a parallelogram. But this time it asks us to use the opposite sides parallel and congruent converse. So on this, we just pick one pair of sides. And for that one pair, we need to show that they are parallel and that they're congruent. So I'm going to pick KL and JM. And I need to show that they're parallel. And I do that by showing they have the same slope. And then I'm going to show that they're congruent by finding their lengths. So parallel, that means I need to find the slope KL first. So I'm just going to do rise over run. We have a rise of 2 and a run of 6. So 2 over 6, which is 1/3. So KL has a slope of 1/3. Then for JM, we have a rise of 2 and a run of 6. So JM also has a slope of 2 over 6, which simplifies to 1/3. So that shows us that they are parallel since they're the same. And then we need to find the length. So we're going to use those same triangles we drew for slope for the Pythagorean theorem. So for KL, our A and our B are 2 and 6, so 2 squared plus 6 squared equals C squared. So C squared is 40, so C is equal to the square root of 40. Now that has a factor of 4 in it, so it simplifies to 2 times the square root of 10. So here's our length of KL. Be sure you identify what you're finding. Now we're finding the length of JM. And we notice that this triangle also has a leg of 2 and a leg of 6. So again, our work is going to look identical. It may seem a little tedious, but we're proving that we know how to show that they're the same. Just working through the Pythagorean theorem. Square root of 40 equals C, and again that simplifies to 2 times the square root of 10. So we see that those two things are equal. So once we've done both of those and we've proven it with the math, we're now going to make our statement. So we can say, since KL is parallel to our other one, JM, and KL is equal to JM by the opposite, and we're just going to state the theorem, by the opposite sides, parallel and congruent converse. JKLM is a parallelogram. On this first part, since we were talking about the segment KL being parallel to the segment JM, I would put bars over those. Okay, so here we practiced using the opposite sides parallel and congruent converse. Here we practiced the opposite sides converse, showing that they were congruent. But if we go back up to the top, we can also use the parallelogram diagonals converse. That's when we show they have the same midpoint. If you can show that they have the same midpoint, then you would be proving using this. On the opposite angles one, I would need to pretty much tell you what the angles were. You're not going to calculate the angles based on a picture. So mostly when I ask you to prove, you're going to be using the first, the third, and the fourth. Okay, now what I want you to do is you're going to go in your notebook to the page that says, is it a parallelogram? And you're going to look at each one of these drawings and you're going to decide, is it a parallelogram? And then tell me which theorem you could use to tell why it's a parallelogram. So this is like a couple of the examples we just did. But on this you need to tell me, is it one or is it not? It could be that there's not enough information. So if there's not enough information, you can say, nope, we don't know enough, or you can say no, because one of the theorems doesn't work, okay? And then once you're finished with this, you're going to check your answers in the solutions folder. And then when you're finished with that, you're going to use this proving parallelograms sheet, and it's going to give you the shape to graph, and then it's going to tell you which theorem to use to prove that it's a parallelogram.